గుడ్ ఈవినింగ్. ఇప్పుడు మీకు ఆర్గానిక్ కెమిస్ట్రీలో జనరల్ ఆర్గానిక్ కెమిస్ట్రీలో జీఓసిలో మీకు ఎలక్ట్రోఫైల్ అంటే ఏంది, న్యూక్లియోఫైల్ అంటే ఏంది, అండ్ ఆల్సో యాంబిడెంటెడ్ ఫైల్ అంటే ఏంది, నెక్స్ట్ వాటి యొక్క టైప్స్ ఆఫ్ రియాక్షన్స్, ఎడిషన్, substitution, elimination reactions. Next after that I will discuss about the stability of the carbocation, carbene ion, free radical. These are we have to discuss. First I will topic electrophile. What is electrophile? Electrophiles are electron loving species. These are electron deficient, electron loving species. These are having electron deficient. For example, if you take H plus, this is having one electron deficient, that's why it is a electrophile. If you take nucleophile, these are having two characteristics: nucleus loving species, electron rich species, nucleus loving, this is electrons loving. This is, for example, if you take OH minus, this is having negative charge, OH minus, this is having, this is nucleophile, this is electrophile. Electron loving species are called electrophile, electron deficient, nucleus loving species are called nucleophiles, and these are having electron rich species. This is one of the example. Next, ambiophiles. Ambiophiles are amphiphils. These are having two characters. One is electron rich and electron deficient sites. Electron acts as an electrophile and as nucleophile. Acts as electrophile as well as nucleophile. For example, if you take this is having acts as electron donating species, nucleophile. This center as having a electrophile. This is because this is having nucleophilic center. This is nucleophilic center. It attracts the electrophile. This is nucleophilic center. It attracts electrophile. This is electrophilic center. This is approach this nucleus. This is having octet 1, 2, 3, 4, 5, 6, 7. By sharing these two electrons, you will get the octet configuration. By sharing these carbon also, you get octet. This is approach the nucleus towards the carbon atom because electron deficient atom. This is oxygen. This is having approach towards the nucleophilic center. For example, if you take cyanide, you take C triple bond N. This is having donates. This is approach donate the electrons towards the electrophilic center. That's why this is acts as a nucleophile. If nucleophile approach towards the carbon, that's why this is having electrophilic center. That's why this is a molecule having both properties, acts as electrophile as well as nucleophile. This is one of the example. Electrophile and nucleophiles. if you give an example, you can also identify the what is electrophile and which one is nucleophile or electrophile. Identify whether a species is electrophile or nucleophile. Next, identify the types of reactions. Next, we have to discuss types of reactions. Types of reactions. Different types of. First, you have to discuss addition reactions. Which molecule shows addition reactions? Addition reactions. If you take any substrate A reacts with B reagent, will form AB molecule. This is called as the addition reaction. In this case, we have to discuss different reactions. One is electrophilic addition reactions. Electrophilic addition reaction. In this case, we take, for example, alkene CH2 double bond CH2. It reacts with HBr. It will form CH3 CH2 Br. This is having H plus and Br minus. This alkene acts as a nucleophile, approaching nucleophile. Then it will shift it to this. In this case, Br minus by H plus ion. It attacked, after that Br attacked to here. Then it will form CH3. These H plus ions will add this molecule. This is electrophilic addition. This electrophile will add it. This plus and minus, this negative charge approach to this positive H plus electrophile. By adding this is called as that's why this is called as electrophilic addition. This alkene, alkyne and benzene acts as an electrophile. In this case, alkene and alkyne and benzene acts as a nucleophiles. Alkene, alkyne, benzene acts as a nucleophile. That's why this is, by addition of this H plus ions, it will form the molecule that is called ethyl bromide. This is electrophilic addition. Next, we have to discuss nucleophilic addition. Nucleophilic addition reaction. To take, for example, what is a nucleophilic addition reaction? To take carbonyl molecule, to take, for example, HCN, cyanide minus H plus. This is acts as the electrophilic center. This nucleophile approach to this one. This will form like this molecule, OH and cyanide. This is called as a electrophilic addition, nucleophilic addition. This is electrophilic addition. This is nucleophilic addition. One more addition, free radical addition. One more addition reaction I have to discuss. That is free radical addition reactions. Third one is free radical addition reaction. What is free radical addition reaction? If you take, for example, alkene. Take, for example, alkene. Take HBr. But in this case, we have to take reagent that is acting as a peroxide, alkyl peroxide. By putting this one, phenyl, for example, this will form the free radical. It will break the H radical. That is addition. These two radicals are added here equally. Then we will form CH2 CHBr. In case of, in presence of peroxide, we will form the free radical addition reactions. Free radical addition reaction. These are the three type of addition reactions. One is electrophilic addition, nucleophilic addition and free radical addition. Next, we have to discuss substitution reaction. One of the conditions, aliphatic pi bond containing compounds, aliphatic fiber bonding compound containing compounds will form addition reactions. Aliphatic fiber bonding containing compounds will form the addition reactions. This you have to remember. Next we discuss about the substitution reactions. Second one is substitution reactions. Substitution reactions. These are also having three types. One is electrophilic substitution reactions. First, electrophilic substitution reactions. If we take for example benzene reacts with HBr, it will form bromobenzene. This is electrophilic substitution reaction. H plus Br minus by in this case substitution reaction, for example A in the living group, B molecule, B as approached here, then living group AB will form and living group. This is called a substitution reaction. If we take any electrophile here, this is called as a electrophilic substitution reactions. Means this hydrogen, this will form H plus, electrophile approach and electrophile remove. That is called electrophilic substitution reaction. Next we have to, in case of this one more is nucleophilic substitution reactions. Take nucleophilic substitution reactions. Second one is nucleophilic substitution reactions. Nucleophilic substitution reaction. What are the nucleophilic substitution reaction? If you take for example alkyl halide, if you take any nucleophile, then it will approach this one, this is releases, this is formed alkyl plus X minus. This is one nucleophile come towards the cell, one nucleophile is leaving. This is called as nucleophilic substitution reactions. One more third one is free radical substitution reactions. Free radical substitution reaction. In this case, we take for example methane. By methane, if we take chlorine radical, it will form CH3Cl plus HCl in presence of HNO, will form the free radical substitution reaction. This is free radical substitution reaction. These are the types of reactions in the chemistry. One more type of reaction, that is elimination reaction. Third type of reaction, that is called elimination reaction. Third type is elimination reactions. Third type is elimination reactions. Removal of two atoms or groups. If removal of two atoms or groups, if removal of two atoms or groups to form alkene or alkyne as a product is known as elimination reaction. If removal of two atoms or groups to form alkene or alkyne is known as a elimination reactions. For example, if you take any chlorine and hydrogen, if you put alcoholic KOH, these two will form alkene. This is known as a elimination reaction. By elimination of these two atoms or groups is known as a elimination reaction. This is one of the important topic. Next, after that, you have to find out the reactive intermediates, stability of the reactive intermediates. Next we have to discuss the then if you find carbocation, this carbene ion, next free radical. First you have to take hybridization. This is sp2 hybridized with the orbital. This is sp3 hybridized. This is same like sp2 hybridized. This is shape of the molecule, trigonal planar. This is trigonal pyramidal. This is also trigonal planar. Next, this is axis Lewis acid. This is Lewis base. This is also deficient electron, Lewis acid. This is diamagnetic. This is also dia because lone pair. This is also dia. If you take in this case molecule, if you take, this is back bond, this stability is there. After that aromaticity existed, mesomeric, hyperconjugation and inductive. That's in case of stability. Here also back bonding, stability, aromaticity, mesomeric and hyperconjugation and inductive. But in this case there is no possibility of aromaticity, only mesomeric and hyperconjugation and inductive effect will show this free radical. But in case of this one, the stability depends upon like this only. You have to measure it. Next, in case of delocalization, it will not change. Delocalization not change the structure and above properties. In case of delocalization, it will change all properties. It is sp2 hybridized. In case of delocalization, this is the localized. In case of delocalization, what will happen? In case of delocalization, it is negative charge. This involved in the conjugation, they will form. Because this negative charge is converted into pi bond, that's why this is not considered as a in the hybridization. Only 1 2 sigma bond will participate in the hybridization. That's why this is sp2 hybridized. But in case of positive charge, it will both are same. In case of free radical also will same. This is the effects of the, how will show the effects, stability of the molecule. By giving some of the example, we can identify these are the properties of the molecules. After so far this, we concluded the general organic chemistry. Next we discussed about the alkane and alkyne. Thank you very much. పైన ఎప్పుడు